is the mass, right? Of an electron.
Yeah.
Okay. So between the electrodes of a cathode ray tube, it moves a distance of 4 millimeters. Convert that to meters. Eli, did you convert it?
No.
No? Okay. There's one more conversion. No, that should be it for conversions. Okay. It's accelerated by a net force.
It's 4,000. No, it's radiant meters.
Starts from rest. It wants you to find the final velocity, does it not? Acceleration and final velocity. Okay, so what's the first thing you want to find? Eli?
Probably your acceleration.
And how would you get your acceleration?
The total distance by I don't know.
There's an easier way to get it. What's the first thing you learned in this unit? What's net force equal to?
Mass times acceleration.
Do you have your mass?
Yeah.
Do you have your net force?
Yes.
Can you
Oh,
get
you
your
divide, oh, I see.
Once you have your acceleration here, Eli, now I use D, V1, V2 to get it.
Yeah, I see now.
Okay? So this whole unit, at some point you're going to use your net force at some point, and then you're either going to go to the old equations or you're going to use the old equations and then work with your net force. Does that make sense?
Yeah.
So acceleration comes from those two. Okay? And you have to remember to convert to meters. That was the other thing too. Alright? Sam?
Page 143, number 4. I don't know how to draw the picture.
Oh yeah. Okay, make sure everybody's following this. We did this yesterday in terms of drawing the picture for this, but you are going to see this and then it gets more complicated because I add a pulley to this, so you must know how to do the correct diagrams for this. So here's what happens. I have a box that slides down a slope. Okay? First things first, what's the first thing that I usually always do in terms of my forces on this? Force of gravity. Which way does the force of gravity work?
Straight down.
Force of gravity works straight down. So there's my force of gravity. Okay? What's holding the box up from coming through the ground?
Normal.
Force normal. And which way does it work?
Up from the surface.
Perpendicular to the surface, right? So I'm going to draw it like that, in which this is a right angle right here. What's the force in the direction of motion now? Force applied in where is the direction of motion? Yeah, how do I describe that to somebody that doesn't know?
Like parallel to the ground, basically, that's your one.
Parallel to the slope, that's right. So it goes like this, right? So this would be your applied force right here. Okay? Now, I also draw it down here. So So what I'm trying to do here is I'm trying to set this up so that I have a way in which I can solve for this. Okay? This creates a right angle because this line here is this line. This line is the one that runs parallel and it creates a right angle, just the same as it does right here. So what I've done,
Bless you.
what I've done is I've created a right triangle in which I can start solving the information. What's the last force that I don't have added onto here yet?
Friction.
Friction. If there is friction in the question, it would be directly against the motion, which is against your applied force. So,
Bless you.
so your net force is equal to your applied force minus your force of friction. That's the way I set up every question to start with. Now, that's 15 degrees, right? Slope of the hill. I'm not going to explain it. All you need to know is that this is also 15 degrees right here on that triangle. So which part of this triangle that I've drawn here is your hypotenuse? Pardon me? FG, your force of gravity. Okay? Which side's opposite of your 15 degrees?
Normal. Oh no.
FA. Which one's adjacent to it? FN. Okay, so I've just created a right triangle. Let me do this with the colors. Makes it look better. So I got black. I've got red. Blue. So I've got FA. FN. FG. 15 degrees right there. Right angle right here. This is given to us as 20 newtons down, right? Right? Samantha?
Yeah, I get that part.
Okay. From there, I'm going to leave it.
Okay.
You can solve it. All right? No problem. So you are going to see this again in at least two more situations. One in which you have a frictional force, and a second in which we're going to add a pulley to the system in the next unit. So you must know how, you need to know how to draw that triangle below. This is not how they set it up in the book again. But this to me is the way to set it up that it makes the most amount of sense for people. Just by extending my lines. Okay? It's an easy question as long as you can draw out this. The biggest thing is your force of gravity is your hypotenuse. Okay? Your applied force is parallel to the slope at which you're going on. Alright? You good now?
Yeah, thank you.
Okay.
Christina, are you having that pre-practice today or tomorrow?
We'll talk in class. Okay. Any other questions today?
Oh, yeah, sorry. Number 5.
Same page.
I got the answer, but I didn't understand why you had to times it by 2.
I just found the one side, the left
Yeah.
side of it.
Yeah, and then I looked at the answer, it was half of it, whichever one.
Speedboat pulling 2 water skiers using 2 ropes attached to the boat. Each rope makes an angle of 30 degrees on either side of the boat's axis. So you got this, you got this, right? Where's the 30 degrees?
Inside? Oh no, would it be outside?
Yeah.
Oh, okay.
It's on outside of both, and then
So
inside
it's
would
right
be
here?
120.
Right there
Yeah.
and right there. So what does that make this angle right here? 120 degrees? Okay? Now, because you have the same angle and the same amount of force, So each of these is the same. There's not going to be any up or down motion. Right? So what you've got to do then is you've got to find this being 60 degrees right here, you've got to find this here and this here, which doubles what you're doing.
Yeah, I just put the angles inside.
You use 30s instead of 60s.
Yeah.
Okay. Okay, so you're good now?
Yeah.
All right. Okay. That should about cover all of the practice problems, right? Now today you should be able to get on to the, although there's 147, there's 5 questions on 147 that you should have to complete as well. 4 questions on 147. So once you're done with that, then you can get into your review. All right? Okay, you have the rest of the class to work today. Yeah.
If you're wanting to walk, I'll get my calculator.
Sure.
I have my